All right, so I wanted to follow up the last video with this one where we're talking about complex roots. And here I wanted to show you a cubic equation and use the graph to find all three of the roots. So I mentioned that one of the nice things about complex numbers is if you think about complex numbers, then you always have n roots if n is the degree of your polynomial. Meaning, if you've got a cubic that's degree 3, you're going to have 3 roots. Even though you can only see one real root on the graph, you will find 2 complex roots. And those 2 roots are going to be conjugates. So if you find one, you automatically have the other one. If you had a degree 17 polynomial, you'd have 17 roots. It would just be a lot more work to find them all. So let's look at this example here. I typed in a cubic equation, and I can see that it hits the x-axis at one spot, at 3, 0. So what I know based on if 3, 0 is a root, then that means that x minus 3 is a power. So I can take my original polynomial and divide it by x minus 3. So it's something we practiced, but it's been a little bit since we've practiced it. X times what makes x cubed? So I'm dividing x cubed by x, and I get x squared. Outsides multiply to fill in the insides, so there's negative 3x squared. Now my original polynomial had positive 3x squared. The insides add up, like terms add up, so I need to add positive 6x squared to get up to positive 3x squared. Now I'm dividing. 6x squared divided by x makes 6x. Outsides multiply to make negative 18x. Insides add up, like terms add up. I have to get to negative 8x. So I do positive 10x because negative 18 plus 10 makes negative 8. 10x divided by x is 10. 10 times negative 3 is 30. That just double checks that I did it right. So what I've done now is I have taken my original polynomial and I factored it. I hate how it does that. Like shifts it around on me. I can take my original polynomial. Maybe I'll do it this way. Nope, doesn't work that way. Okay. It becomes x minus 3, x squared plus 6x plus 10. And what you can see is that I have now graphed directly on top of it. What I can do now is what I was doing in the earlier video, where I can factor what's left over, the x squared plus 6x plus 10. Okay? Sorry, the formatting gets a little wonky there. If I look at x squared plus 6x plus 10 and you try to factor it, you won't be able to. The only way to multiply to make 10, is either 1 times 10 or 2 times 5, and neither of those add up to make 6. And so what we do instead is use the quadratic formula. So negative b plus or minus square root b squared minus 4ac all divided by 2a. So that gives me negative 6 plus or minus square root 36 minus 40 divided by 2. 36 minus 40 is negative 4. And the square root of negative 4 is 2i. Okay, it's 2i because the square root of regular 4 is regular 2. So the square root of negative 4 is 2i. And if that's divided by 2, I can divide 6 by 2 and 2i by 2. So I have negative 3 plus or minus I. So what I have now is my fully factored form for my polynomial. I have x minus 3, that's the real root, x minus negative 3 plus I, that's one of my complex roots, and then my other complex root is x minus negative 3 minus I, and that's my factored form. Okay, so I just want to show you this, that it's sort of taking what we learned when we studied polynomials and we did polynomial division. We divided based on one root that we could see, and then we used the quadratic formula to find the other roots. It's the same idea. It's just that some of the roots are now complex. So you use the quadratic formula and you get a pair of complex conjugates. Okay, thanks for watching. Please let me know if you have any questions.